Yes, welcome to yet another class, and we want to review what we did yesterday. And what we were doing yesterday basically was an a data manipulation using the ggplot. Sorry, using dplyr. And again, of course, we mix it again, mixed dplyr and ggplot to produce some graphs. Yeah. And so one of the things that we really found useful yesterday was the pipe operator, right? The pipe operator. The shortcut for this pipe operator is a control shift. And you can see that one of the important things about it is that it's a powerful tool for simplifying a series of operations or functions in a more readable and organized manner. This is a powerful tool for simplifying and chaining together a series of operations or functions in a more readable manner. And we looked at functions like filtering, right? You can see that you can even filter an iris dataset, the iris dataset, so that it is showing you sepal lengths that are greater than 5. Iris dataset is here, and sepal length that are greater than 5 are the only ones that are going to be shown. If you have a sepal length that is less than 5, then that one is not going to be shown, right? So that is what we are trying to filter now. Let's see if there is any value, any sepal length that is less than 5. For example, you can see number 107. This one is not going to be shown. So we are filtering out. If you don't fall within the condition that you're specifying, you're not going to be returned. So for example, that 4.9 is not going to be returned. And we have others like 4.9, number 58, also not going to be returned. And you have 4.8, 4.4, this 4.9, 4.9, 4.7, 4.8, 4.6, and others. So it is not going to be returned when we filter for sepal length that is greater than 5. We can even filter for the one that is less than 5. And even 5 is not going to be shown. If you are 5.0, you're not going to be shown because we want that one which is greater than 5. Yeah, that is the essence of filtering, right? And then after doing all that filtering, we want to summarize this data. But now we want to summarize it using petal width. Let me just write this one so that you see the output. Okay, you can see the output here. Let's write. So this one is a flattened form of this equation that we wrote here, or this code that we wrote here, except leaving out this. So you can see that we are going to filter iris dataset, and then you are filtering by sepal length greater than 5. So let's try to see this. You can see sepal lengths that are greater than 5 had been returned. And now we have 118. Initially, we had 150 rows, right? Initially, we had 150 rows. So after doing this, we want to summarize by getting the mean of the petal width. You can see that is what you're trying to summarize here, mean petal width. And then when you get that, let's print result 1. And you can see that the mean of the petal width is 1.432203. So let's see petal width. So petal width is here. So you're going to basically sum 0.2, whether it is from setosa, whether it is from versicolor, or whether it is from virginica. You're going to add all of them and then divide by 118. That is what you are trying to do. We can as well even summarize it by sepal length, right? The sepal length that we are using. Sepal length and summarize it. Yeah, if you run it and then print result, this result, you'll see that it is 6.129661, right? And then there's another, so that is filtering, right? Yesterday again we looked at chaining other series of functions like or codes like we are using filter, then we are using arrange, basically arranging them whether from in ascending or descending order, and then selecting specific columns. So you can see result 2, tickers, piping it to filter, right? So the data set that you're using is empty cars that we had covered yesterday. And also what you want to filter is filter for MPG that is greater than 20. Then you want to arrange them in descending order. I wrote this group by here on purpose. I'll explain why it is on purpose. Group by that, and then you want to select MPG cylinders that are greater than HP. And we want to select, sorry, the MPG cylinders and then the HP, and then print the result. So if you try to run this one, if you try to run this line of code and this, you'll see that we have cylinder 4, 4, and 6, though we wrote a group by here. We wrote a group by here. It has not been grouped into the 4s and the 6s, right? That is one thing that you may notice. So why I'm saying that is because we need to determine the order that even some of these conditions follow. If you check maybe line number 4, that the first thing we are doing here is to group them. Group and then summarize. After summarizing the mean, MPG, and things like that, then we now arrange. So of course, this one is we are getting the mean after grouping them. So it's either a cylinder of 4, right? You have a cylinder, a car has the cylinders of 8 or 6. So we are trying to group them. After grouping them, then we find the mean as per the cylinders, right? After doing that, we are arranging that result in descending order, right? If you try to run this one and print the result, you can see that we have 4, 6, 8. Yeah, we are arranging them in descending order: 26.7, 19.7, 15.1. If we decided to arrange them or change it to cylinder and then print result, you can see now we are arranging them in descending order from cylinder number 8, 6, 4, right? Yeah, that is just the change that you can do here. So we have here we were using mean MPG. No worries. Let's try to edit this one and see if it makes sense here. So after grouping by, let's group by, Control X, and then place it here. So this one we can remove it here and run it and print our result. Why is it not grouping? So group by, oh, okay, we are not doing any sort of summarizing again. Let's see. Yeah, because even if we group by cylinder, let me see, arrange, descending. Yeah, unless maybe we could summarize it again the same way we have this one here, then it will make sense. But here we are not doing any summarizing or anything like that. Group by cylinder and then arrange this as MPG. Select MPG cylinder. Yeah, which of course it's true. Let me see if we change it from this position to up here, so that we have it as the, yeah, we want to see if the position that, yeah, but of course these are things that we did yesterday. and let's see what we have. Yeah, still it's not working for us unless we yeah, if we are to do a summary, right, that will make sense, I believe. Group by CL and filter the MPGs that are greater than 20, arrange in descending as compared, and then select. Yes, I believe. Or let's see this 21.4. What it is? Which kind of car it is? 21.4 and falling on 6. Let's see the iris if we can find that information, because I might be missing something. And control enter. Sorry, we're supposed to be using empty cars. There's one whose MPG is 21.4. Volvo is number that. Do you have another 21.4? Hornet 4 drive 6 and 4. That is completely different. Yeah. So basically, what I mean is, if we could be doing like some summarizing it using, for example, this one, then it will make sense. But group by needs to come in the early stages, even after filtering or before filtering. You can see, for example, this one. All right. Another thing we looked at, of course, is combining dplyr functions and ggplot, right? And after doing the filtering, for example, here we filtered empty cars for MPG greater than 20, just what we did here for MPG greater than 20, right? And then now piped it to create now a plot from it. ggplot aesthetic x is equaling to wt, y is equaling to mpg, yeah, and geom point and the likes. Yeah. So you can see here, empty gas filter mpg, that one we had covered, and then now we are taking it to create a scatter plot with it, right? And I'd mentioned to you, maybe let's just review that. This is how you can write ggplots functions. So ggplot, and then you can see here data is equaling to, then mapping, aesthetics, and things like that, right? So data that we are using is equaling to empty cars. I'm giving you a skeleton first. Empty cars mapping is equaling to aesthetic. Then x maybe we want to have the cylinder, and the y we want to have the mpg, right? You can see what we have here. But if we run it as it is right now, it's going to run, but you're going to have a blank graph. So this is the first thing that we are going to have, all right? But now we have to introduce, what are we trying to visualize? Maybe you want to see the geom point. This one, geom point. We have to draw yeah, this kind of a scatter plot, right? But of course, this one you can't use it for. Let me just check it for you. Yeah, it's not going to produce, because this data is not that one that we can use for a bar graph. Even if you try something like geom hist, yeah, because we have not even declared bandwidth or things like that. So this one we can use for doing a scatter plot, and that is something that now can be produced, right? Again, another thing that I also mentioned is this thing that you've written here, all of this, it can again be even written this way: ggplot data is equaling to empty cars. Okay, data is equaling to empty cars. Okay, let's try it this way: empty cars, and then you say aesthetic x we map cylinder, y we take mpg, right? And then we say plus geom point. You see it's still running, right? We don't have to say data is equaling to empty cars, mapping is equaling to aesthetics, blah blah. This other one, similarly, we can even write it this way: ggplot. Then we say empty cars, right? And then after saying empty cars, we add plus geom point, and then say now, here is where we say mapping is equaling to aesthetic. You can write mapping is equaling to aesthetic, right? Aesthetics, and then what are our aesthetics that we are trying to use? Yet we will use x is equaling to cylinder, y is equaling to mpg, right? And then now run it, and you'll see it's still producing the plot here, right? Similarly, this one again, you can just even remove this. Yeah, you can just remove that and run it. Still it is producing. So this is just simplifying your codes. You can write it this way, you can write it this way, you can write it this way. So, depending on the way you want, right? Uh, let's see. Color to be equaling to, yeah, you can see the color gradients that we, if we add the concept of color is equaling to cylinder, so that we separate them as per the cylinders. So if you are light blue, this light blue, you'll go for the 8, right? Of course, it's checking whether 7, 6, and the 5s also have have some data entries, but only 6 is there. So 4 is a little bit darker, right? So you can say color is equal to cylinder. But of course, here we can't use, we can use fill, but let's see. Yeah, fill is going to produce the more or less the same thing, right? If you try filling, but you'll see now the color differences, right? Are you seeing how the color aren't really different? So the best thing here to use is the color. Color is equaling to seal, and then you can see the differences: light, in the middle, dark. Yeah, that is that. Or you can even say color is equaling to, how about if you say color is equaling to red? You can see now your color is, you're coloring all of them at once. So those are things that we covered. Yeah. So that is the basic outlook of ggplot. Then now this information, that is what we have pumped here. Of course, we've added now the elements of, we want to label the x-axis. We want to change it from this cylinder and mpg, and then let's run it first and see. And maybe have it here that color is equaling to cylinder. And then you can see the scatter plot that has been generated here. This is a different one, right? And you can see the scatter plot that has been generated here. So miles per gallon, weight, or you can even just say color is equaling to yellow, or maybe green. But of course, this one has to be in. This one has to be in quotes. Sorry, I've written a wrong thing. Unexpected symbol. Where is the symbol coming from? Unexpected symbol in filter MPG. Where is our issue coming from? Okay, let me cut this and have it here. Let's see the difference. Yeah, now you can see. So the color you place it in the geom, you can see now the color has changed from that to even blue. Sorry for that. And then you have it, yes, this way. So in your geoms, you place the color that you want there. That is that. You can even see here you're already hanging with this color being right. So today we are also supposed to look at more plots on ggplot. Of course, I've talked about it here, but just different geoms in action now. Scatterplot we have already built using geom point, and that is what has produced this one, right? So data, empty cars, aesthetic, this one we had already built. Then the area that you can focus on is this one. Labels, right? X is equaling to horsepower, Y is equaling to miles per gallon, the miles per gallon. And then you're giving it a title. The GG title is scatterplot of MPG versus horsepower in empty cars. That is the main title, right? Or you could have even said up here title. Sorry. Okay, we have already had it as GG title. Let me add here something subtitle. Uh, Subtitle to be equaling to just say maybe scatter plot example 1. Scatter plot example 1. You can see this. Sorry, you can see under it here there is a subtitle. Title under the main title, right? Can have it that way. That is a subtitle. Another thing that is creating, so here we are using the data. You have to declare what you're using, empty cars, map your aesthetics. So you don't have to write this data is equaling to, right? You can even remove it and it's still going to run, right? You can see that it's still producing. Another thing is creating a box plot. What is a box plot, by the way? A box plot is just a 5-point summary of a numerical data set. And one of the things that a box plot gives you, it gives you the minimum value, minimum value, or maybe minimum data point, minimum, it gives you the maximum, right? It also gives you what we call first quartile, right? First quartile of your data. It gives you the second quartile, but this second quartile is what we call the median, right? It's called the median. And it also gives you third quartile. The upper 25%. So first quartile, the first 25%. Second quartile, it's more of like dividing your data into half, right? That is the basic understanding of quartiles. So you can see that this is one data. Sorry, this is one, then we have two, then we have three, then we have four, then we have five. So scatterplot gives you a 5-point summary of your data set, mostly of your numerical data set, right? So for example, if we check this one, we want to to use the iris data set, right? And we've used iris data set for quite a while now. Iris data set and map it, of course, X, we want to have the species. Let me just view iris dataset so that you know what we are talking about. So this is the dataset that we are using. sepal width, petal length, petal width, species. Yeah. And then now we want to use on the x-axis, we want to plot, we have to have the species on the x-axis. So if you're setosa, we are going to have information on x-axis, versicolor, and virginica, right? On the x-axis. Y is equaling to sepal dot length, color is equaling to species. Yeah. Y to be equaling to sepal dot length, color to be equaling to species. Then what again that we want to do now is um, is using the box plot, geom box plot. Geom box plot, you can again do the mapping is equaling to blah blah, right, and things like that. But we can let us just keep it simple for now. There are other information that we can add inside here apart from the possibility of just adding this one, right? Okay, yeah. But ggplot inside it, like you have to declare which data you're using. Iris, that is okay. If you leave it open, uh, you might be digging a different grave. So for example, let me show you an example where you are writing. So suppose that you don't declare empty cast here and go ahead to declare empty cast here. Let's see what happens. You see, mapping must be created by an aesthetic or something. There's error in geom point. ggplot, if you try running it with without the data here, there are issues that come along, which you don't want to be part of. Yes, so we have this one, Control V, and yeah. So we are here. So of course, label. We want to label the X that it is the species that you're taking there. And then we want to see the sepal lengths of different kind of species, right? We want to see the summary of the sepal lengths of various species. We have 3 species, right? Then of course the title here you can say box plot of sepal length by species in iris. In iris, you can even add iris dataset. Right? There's no harm in doing that. Right? So if you run this one, all right, you can, oh, of course I added color is equaling to species here. Let's first remove this color is equaling to species and just write it. You can see how it is. Setosa. So here, where this line is starting here, it is the minimum value. Where this line is almost ending here, it is the maximum value. So this first line here, this lower line here, this is the first quartile. The middle one is the second quartile, the median, and then we have the upper quartile, right? Similar to this one. You can see what is happening with Virginica here. It is telling us that we have a certain outlier. So that is also, you can see that this is very far away from the values that you have here. So this one is an outlier. The moment you see this dot, it is an outlier, right? You can see also this line doesn't have to be in the middle exactly. So why it is not even now in the middle is because of this outlier. Outlier is 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 um is affecting our analysis, right? It is now showing us that the median is a little bit lower, while the median could have been mostly towards the middle, if not completely in the middle. For example, this one is towards the middle, but it is not in the middle. Yeah, so this outlier is affecting our data here. Another thing, you may want to see different colors for different species, right? And that is where I initially had here the color is equaling to species. So that you can see for Setosa we are using the red, and on this one you're using a different color similar to this one, right? We can even add it as fill. We want to fill is equaling to species. So you can see different how color and fill is different from each other. Here we have box plot of sepal length. Here we have, of course, species, and that is the labels that we are using for our data. I believe that one is very clear. All right. Yeah. So you can see a question here. What is the difference between color and fill? Yeah. Example 3. Now we want to use the histogram. Yeah. You want to use the histogram. Try using the histogram and see. But now we are using a different data set, of course. We are using a data set called faithful. And for you to get more information about faithful, you can look at the data, the eruptions, and the weighting. Maybe that information is not enough for you. Go and write this line, question mark faithful. Then you will see that the description of this faithful data, its waiting time between eruptions and the duration of eruption for the old faithful geyser in Yellowstone Park, USA, right? Okay. So it is a data frame with 272 observations on two variables: eruptions, numeric eruption time in minutes, waiting time, numeric waiting time for next eruption, right? So you can see that one, it's a data from maybe 1991. So that you know what those two columns mean, what eruptions mean, and what is the waiting time. These are just the waiting time for the next eruption, right? This one is eruption time in minutes. So it has erupted for 2.283 minutes, 4.583, and things like that. So what you want to do is to create a histogram, yeah, where of course the x-axis will be having the eruptions. On the x-axis we'll be having the eruptions, and we'll be seeing more or less frequency of eruptions per every x data point, right? And you can see here, geom histogram, bin width, we are saying is equaling to 0.2, fill is equaling to purple, color is equaling to green. These ones are labels. So we'll look at what these two things are telling us. But let's first run it. And you can see here, fill inside the histograms, or maybe those bars, we are filling it with color purple. And again, on the outlines of the bars, we are filling it with green. You know what I mean? You can even change this one to even uh, orange. Oh, let's see if orange is going to work. Okay, yeah, that one. You write it in small letters. Color is equaling to, ladies are good with colors. Let me say, what is the color of a rainbow? There's one starting with V. Maybe you remind me. Yeah. What are the colors of the rainbow? There's that color. Oh, there's indigo, there's violet. Let's say violet and see if it's working. Or indigo. Is indigo going to work? Invalid color name called indigo. Okay. Let's use this violet that looks like it is purple. Yeah, you can see now this is orange, and then the outline is that. But when we have blue, you can even have blue here. Yeah, you can now see the outline is clear. Now, how about if we change this bandwidth to maybe 1? You can see that the number of bars has reduced, right? How about if we change it to 8? Of course, 8 is too big. You can see that now we have only 2 bars. How about you change it to 10? Again, we have 1 bar and 1 small one. Yeah. The more you change the bin width, like you are So for example, from here, -5 up to 5, that is 10. We are now looking at the frequency of data points between 5 and 15. That is also 10. The bin width is 10, 10. So you can see that for 10 tens, for 5 up to 15, there are not so many data. The data is concentrated between -5 and 5. Let's get it to, let's see if we have 20. Yeah, for 20 now you can see it's just 1. We are seeing that data in -10 up to 10. That is basically 20. We are seeing it in one large bar, which maybe is not really okay. So you can have this one as maybe 0.01, so that you have differences. The differences are really small if you have it as a low bin width, right? How about if you have it as 0.1? So you can see how it changes. You have it as 0.5, and you see a different thing altogether. Yeah, so you can play around with that and see that. You can also plot a line plot using air quality dataset. There's the dataset called air quality, which you can also just view and say air quality, right? Air quality, ozone, solar, wind, temp, and it's 153 entries of 6 columns, right? Yeah. For you to get more information about it, similar to what we did, air quality. Yeah. Look for information. It's data daily air quality measurements in New York, May to September 1973. Ozone, numeric ozone. Solar, numeric solar. Wind, numeric wind. All these are, it's a numeric data type. Day of the month from 1 up to 31. Numeric month, of course, 1 up to 12. Yeah. So you can see ggplot data is equaling to air quality, aesthetic, x is equaling to day, y is equaling to ozone, then geom line, color is equaling to green. We are using color is equaling to label and things like that. So we want to plot day versus y ozone, like we want to see the what we have here, the things that you have here. Ozone is mean ozone in parts per billion from 1300 to 1500 hours at Roosevelt Island. If you run this one, you can see that the graph that we are producing. Of course, it's a disjointed lines, yeah, but that is how you could use a line. You even done a subtitle here, basic graph, and things of that sort. I mean, these are just reproducing what you have been doing here, but with different data sets and also different geoms. You can also even look at geom bar chart, whereby for geom bar chart we only have the x-axis, right? We only have data for the x-axis. Y will just be count. Yeah, it is going to aggregate. Okay, let's see diamonds. Diamond prices of 50,000 round cut diamonds. So a dataset containing the prices and other attributes of almost 54,000 diamonds. A data frame with 53,940 rows and 10 variables, price in US dollars, carat, weight. You can check on that information. Then what you want to print is X, you want to see the cut, the quality of the cut. Is it fair, good, very good, premium, ideal, right? And then if it's going to see the frequency of fair and put it as count, right? How many how many diamonds fall for fair when as per the quality of the cut? How many of them fall for good, right? That is the bar graph, right? So you can run this one and see that we have fair. It's about so this is 25,000. This is about this is about 16 or 17. Good is almost in 5,000, right? Good is almost in 5,000. This one is again very good, and you can see all that. But you may want to see it by, okay. You can say color is equaling to color is equaling to cut, and run it and see. You can see the borders are having different colors for them, but that one cannot make sense. Not really cannot make sense, but it's not showing us the difference very much. Now you can see now the difference that we have here. Yeah, fair, good, very good, premium, and ideal. So you can really see how beautiful now it is. Okay, a scatter plot again that we had already talked about there, but now we are introducing a regression line. We want to see create a scatter plot with the regression line of car weight versus miles per gallon. Yeah, so you can see ggplot here, data is equaling to empty cars, right? So which empty cars, of course, you've seen it for quite a while now. But now we want to see car weight versus miles per gallon. What you have the weight versus miles per gallon, and see the trend, right? First, even before having this geom smooth, let's first run Control Z. Let's first run this one. Here you can see the trend here, or the trend, or maybe the scatter plot that you built here, right? Yeah. Let's now add these, or we have it from here. Geom. Yeah. There's something that we are adding here called geom smooth. Geom smooth, right? Geom smooth now is what is going to generate for us that line that we want. Yeah. So you can see method is equaling to LM. This is the linear model, linear, right? SE, when you say SE is equaling to this standard error is equaling to T. Of course, it is equaling to true, which you can again even write this way. When you say SE is equaling to true, you're going to see some, are you seeing that shadow around it? What is this shadow? Yeah, some sort of correlation around the line that you're having. If you set it as false, right, and control enter, we are not seeing it, right? Yeah, and then color is equaling to black. Color is equaling to black. That is the color of our line there. So if you have it as color is equaling to green, why am I so much in green? Red. You can see the color changes, right? I want to show you something. So if you do not declare that SE is equaling to false, then automatically we print that the standard error is printed. By default, it is equaling to true, right? By default, it is equaling to true, right? We have omitted the SE here, and you can see all that correlation around has been printed there, right? If you get it back and say false, we are not going to see it. Color is equaling to red. This color you can play around with it and see what it means. So instead of saying SE is equaling to true, you cannot just write it. You can, I mean, just leave it out and find the same thing. So here is where we were, the labels and things like that. That one is so that is where we use geom smooth to print for us that line. Black is not okay for this one. Let's have maybe blue. And then another thing now, the last thing is density plot. You can also create a density plot using the iris dataset. So create a density plot for sepal lengths by species, right? Okay. So iris dataset, I think we had seen it again. So you can also just view it here, right? View and then view the iris dataset. But now we want to see to plot the sepal lengths by their species. So data, of course, iris x is equaling to the sepal length. and then fill we are saying the species. Let's first run this one. So you can see here, if we don't write fill is equaling to this, and then run it, you'll be having just one whole line, right? You'll be having just a one whole view of sepal length, but it is not separated as per the species of that of the sepal length. So that is why we are including fill is equaling to species, so that it aggregates them into, are you a versicolor, are you a virginica, are you a setosa or something, right? And then of course these ones the labels. Sorry, x is equaling to sepal length, y is equaling to the density. So you can see that with this peak, it is telling you where most of the data is concentrated. You can see that there's a peak here. It is telling you that most of the data is concentrated around 5. It's somewhere around 5.1. And you can even view that. View what? View iris. So this one is telling you that for Setosa, most of its data points are concentrated around 5. So let's see Setosa species here, and then we have sepal length. 5.1, 4.9, 4.7, 5.0, 5.4, 4.6, 5.0, 4.4, 5.4, 0.8, 5.8, 0.7, 0.4, 0.1, 1, 4, 1. You can see another one there, 5.0, blah, blah, blah. So it aggregates it and tells you that most of the data is concentrated around 5. It's 5.0, 5.1 ample. Yeah. Let's see if you write here color and see the answer that you are getting. Similar. You can see color is equaling to species. You can see that it's getting us the outlines. So if you look at versicolor also, it's telling you that most of the data is concentrated around 6.3, 6.3.4 up. This one is concentrated around 5.75 up, 5.7, mostly 5.7. You can check it with the x-axis here. Yeah. So that's it. How about if you have alpha is equaling to, let's have it as fill so that you see alpha in action. Change it to maybe 0.1. You can see how it is, right? Change it to 0.001. You can see that we cannot even tell the difference now, right? We are seeing them as just one similar thing, right? How about if you have alpha as 100? The more you have it, the more concentrated the color, right? But of course, when you go past 10,000, we've reached the limit, so you can't really see the difference. So if you have it as 10, sorry, yeah, here it is. But try to reduce it and say maybe alpha as 0 as 4. Okay, that doesn't make sense. Let's have it as 0.6. You can now see it's going down a little bit, right? Yeah, so that's it. That's how to use various kinds of geoms to do your data visualization. And so thank you so much, and I hope you have a nice time practicing geoms in ggplot and come out as the best in doing the plotting. Thank you.